Gug, sir. Genuine students have texted Gug. It's not Gug. It's good. G-O-W. By mistake. By mistake, I got it. So we are live, students, here in front of you. Okay? Just hold on. So I've started this. What we say? What we say? I don't know what we say. Okay, sorry. No need to say sorry. I was just kidding. Okay, I just was making a fun. No need to worry about this. Fine. No need to worry. I was making fun. Okay. Got it. See, hold on. Okay, audibility issues. Are there any audible issue? Video, audibility, anything? मेरी आवाज is clear or not? क्या मेरी आवाज सुन पा रहे हैं? Are you able to hear my voice? Students, are you able to hear my voice? Yes or no? Yes, clear. Okay, cool. So are you ready for the class to start? Any doubts? First of all, text me. Before showing you any of the slides, I want to ask from you. Are you having any doubts? Before starting the class, let me ask from you. Are you having any doubts? Any doubts, students? Any doubts? Any doubts? Any doubts? For doubts, text in the chat box. If no doubts, then I will start the class. If there are some doubts, then we'll see the doubts first. And now this is how the things go, no? Okay, no. Yes, no. If you're having the doubts, please text in the chat box. If you're not having the doubts, then also text in the chat box. Okay. Okay, we are going to start. I think that students are there in JNV Ernakulam. How many students are there? Okay, so it's a good amount of students are there. Let's go. Where's my pen tab key? You can see on the live YouTube also, isn't it? Okay. Welcome to sir also. Okay, so we'll start it now. Okay, I'm closing the video because be focused on the slides. Whenever I need to demonstrate something, I will on my video. Okay? We don't want any network issues. We don't want what? We don't want any network issues. Cool. So let us start this thing. Okay, in the previous class, how much we have completed? We have completed refraction of light. Okay, we have, I mean, this was back-to-back class. Okay, so this slide is not required. Read this. But if we talk about this, that is the previous class. In the previous class, just hold on, students. I'm just going to close the door. You know, the noise is coming. Okay, so I think now it's clear somewhat as compared to the previous voice. Okay, I mean, a lot of noise was there. Okay, first we'll see this numerical. We have seen actually numericals. Okay, apparent depth and normal shift. We have seen just the apparent depth. We'll see today the lateral shift. Then we'll see what is critical angle. Okay, after that, if you're left with some time, we'll see refraction through lenses. After that, if you're left with some time, we'll also do the refraction through lenses. Okay. And also refraction through some spherical surfaces, maybe concave looking or convex looking. It can be anything. Got it, students? Okay. Okay, I'm starting this recording also. So record to the cloud. Okay, so Pravarti, V9 have also joined. Lakshmi have joined. Cool. So you students are back. Good. See, this I will not revise again and again. You know, it makes us feel like very boring, isn't it? It makes us feel very boring, isn't it? Revising the same things again and again. So this laws of refraction you have already seen. Its main part was what? Was the thing which is main here? This one. This is the main thing from the Snell's law. So for applying problems, remember N1 sin I equals to N2 sin I. Okay? This is Snell's law. Okay. If you write the formula for this, formula will be like this. You can see this is the picture. So we write like this: sine of I upon sine of R equals to N2 upon N1, okay, equals to V1 upon V2. Remember these things. देखो इसमें remember करने वाला क्या है? This you can remember like this: N1 cross multiply this application formula. Okay, but proportional mein when you will put this equate N2 upon N1, just change the subscripts. Change the subscripts. Okay. देखो in between if there is any audibility issue, please text in the chat box. Otherwise the session will go like this only. Okay. So write it like this: N2 upon N1. Change the subscripts with the letters. So 1 2 1 2 1 2 1 2 VV lambda lambda. Okay. Now the next thing is solution. See, now it says find the speed of light in a medium A if the speed of light in a medium B is C by 3. Okay, it's given here. Speed of light. See, this question also we have solved. No, what was the answer? C by root 6 somewhere. Okay, some students were having the doubt in this question. So let us see once more. Okay, last time. Okay. So a medium de rakha hai Na, in that the speed is given as C by 3. The second medium is given NB, in which the speed is given, or sorry, C by 3 is in the B medium. Again, I made here error. It is this. Here they're asking us to find the speed. Here it is given by C by 3. In angle A, the angle is 45 degree. In angle B, the angle is 60 degree. We know the relation NA upon NB, VB upon VA. Okay, this was NB, so it will be of sine B. NA, it will be of sine A. Equate the angles. Sine B matlab 60 degrees, sine 60 degree. Sine A matlab 45 degree. Okay, refractive index velocities will be like this. VB is matlab what? VB is C by 3. V is how much? V kitna hoga students? V we need to find. We know sine 60 is root 3 by 2. 45 is 1 by root 2. We'll get the answer as root 3 by root 2. Okay. And it will cross multiply. Okay, so this will be the equation C by 3 VA. Now you have to solve this thing, you will get the answer. Root 3 by 2. I think the answer is changed maybe. C by 3 V. Okay, this is the thing, no? Okay. So you will get VA equals to how much? You'll get like this: C root 2 by 3 3. In the previous class, I've given C by root 6. Maybe that was a mathematical error. Check it out. Okay. So this is a recall question. I mean, yeah. So after this, what we did apparent depth. So this is one of the best topic. Actually, I tell you. I mean, the easiest and the best. Apparent depth of the normal shift. Okay. Apparent depth of the normal shift. You know this thing. He said, suppose this is a fish kind of thing. I'm able to, like, you're able to see this. Okay. Suppose this is a fish kind of, okay. You know, if this is in water, you know this thing, with this photo, you can visualize this. If this is the real depth, this is a real depth. But to you, you will say, if someone asks from you, if you are standing on the top layer like this on the mountain kind of thing, if someone is asking from you, hey, tell what is the depth of the fish, you will say not this, which is a real, but you will say about the apparent. And you are also right with respect to yourself, because the fish will appear there, and you know what's the reason behind that the fish is appearing there. What's the reason that the fish is appearing there? It's due to refraction. Okay. So after this, we have concluded this thing that the real depth is greater than the apparent depth. And you can see this, it's D is greater than D dash. Okay. And then we have concluded some points. See, I haven't removed this annotations. Why? Because this is the previous part. Then we have seen this thing when the object. See, first of all, I don't want to ask you one more thing. Have you revised the things? Have you come with revision? Yes or no? See, if you came with revision, what I will be doing is this. I will stop here and like I will start the today's contents. Okay. I mean, lenses, reflection, and all these things. And if you haven't revised, we'll carry on. So what do you say? Text me in the chat box. Okay, I'm waiting here. You can text in the chat box. If you want the revision to continue, carry on, it's good. Otherwise, we'll start with the lenses or refraction through curved surface like concave or convex. Okay, let us continue from here only. Okay. So after this, what we concluded this thing that when the object is in the denser medium and the observer is in the rarer medium. So for this case, always and always remember this, real depth is always greater than the apparent depth. Okay, real depth का मतलब D, apparent depth का मतलब D dash. Now this thing. This is also image in front of you. You can see in this we have in this what we did mathematical formulation. So any doubts in this? Make your notes yourself. Okay, are you having any doubts in this? Yes or no? Anyone? So what was happening in this? This is n1 upon n2 apparent depth, okay, divided by this is what the real depth. Apparent arises due to what? Due to refraction. Real depth arises due to what? It's natural. Okay, if the stone is lying, so you can see this is the object. Let me show you. This is the object O. It's at a depth D. Okay, and this is what? This is the real depth. This is apparent. Okay, no doubts. So this formula also we have noted down. Okay, and you know N2 is what? The refractive index of the medium where the ray is going, and N1 is what? From where the ray is coming. ठीक? And then we solve this question. देखो इस question के solution में कोई doubt? Yes, no, no, okay. And then we have solved a different case. We have reversed ourselves. So in the first question, we became the bird and we were observing the fish. Okay, so fish will do fish image will be what? This will be the image of the fish, apparent, fake. Okay, distance is D dash, apparent depth. This is the complete depth, real depth. Okay. Now suppose if you become the fish now and I'm observing the bird, so bird will be lying at the back top there. Okay. So these are the conditions. And we have derived the formula for this. We have solved the question also and we got the answer. After this, we have seen this slide. What does it say? Right in front of you. Okay. So on this topic we studied in the previous class, the velocity of the image in case of plane refraction. Velocity of the image in case of plane refraction. इस cases में क्या करना है? Velocity of the image in case of plane refraction. So how is it? Suppose we are having an observer here. Okay, we use the same formula we have derived for the apparent depth. Okay, then we have differentiated both the sides. We got this answer. Ultimately, we have written here the expanded form. This was the expanded form. Got it? You can see yourself. You know? This is what? This is the expanded form. This is the velocity of image which we are observing from the ground frame, velocity of the surface, and are all these things clear? Yes, no. Yes or no? I hope it's clear. See, based on this velocity relation, okay, some student have texted me. Based on this velocity relation, we have solved this question in which the bird was moving. You can see yourself. You know? What we did here, that a bird was moving. Let me show you. Okay, this is a bird. It was moving with 24 centimeter per second. I'm just recalling this. Okay, it was moving. The stolen students. Some audible students. Hello. I hope my voice is audible, na? Okay, so let me check the YouTube first. What is happening there? What the YouTube students are doing? Let us see. Just wait. Okay, it's available there also. Okay. So it's cleared. I hope this question is already clear to you. Okay. So we applied the formulas. I will not waste the time now. Okay. It's useless to solve this question again and again. So this bird was moving. This surface was also moving, and this fish was also moving up. Okay. We applied the formulas here like this. Yes. And then we got what value? Ultimately, we got the value of the image here as this. That is 37 by 4 centimeter per second. Okay. If you compare this value, okay, the first value we got is 33 plus by 4, and then we got what? We added plus 1 with this. So this gives us what? 37 by 4 centimeter per second. If you observe this value, that velocity of the please mute yourself. Okay. So if you observe here, this is 37 by 4 meter per second, which is the velocity of the image as observed by the bird. Okay, velocity of the image of the fish. But if we consider the fish is actually moving with what speed? It is moving with the speed is equals to 12 centimeter per second. Okay, and here 37 by 4 meter per second is this, which is the velocity of the image. Okay, you can see now the original object, which is here the fish, is moving with more speed as compared to this 37 by 4, because 37 by 4 is something what? It is 9 point something centimeter per second. Okay, so this is the observation. By the way, I've given this B part as a homework to all of you. Have you solved it? Students, have you solved this question, the B part? The apparent speed of the bird as observed by the fish. So now it's opposite. Initially, we became the bird, and then we observed the fish speed, or the more precisely, if I say, we have observed the fish, the image speed of the fish. Okay, so image the fish ka uska speed. Now, if we became the fish, and then what will be the speed of the bird's image? Okay, got it. So this was the homework. Anyone give me the answer in the text box. This is not good. You must solve the questions. This is very bad. So what do you say? What is the B part answer? Again, if you haven't solved, I'll not solve it now. I can give you the solution in the PDF, but now I will not solve. It will take, I mean, this was a homework for you. This is not a recall question, by the way. So again, try one more attempt. Okay, if you haven't attempted this question, give 2 or 3, twice or thrice attempt must be given to this question, because this question B part deserves your attempt. Okay. So now let us move towards a fresh topic, a very fresh flowers like looking topic. This is what? Refraction through a glass slab. Are you ready for this? So now not forget, the thing is this, now we have come to the second topic in the progression of this chapter, that is the ray optics. So soon we'll complete it. If we're going with this pace, we'll complete this in the next week, more precisely. Got it? Okay. So write the heading in the notes, refraction through a glass slab. Write this heading. See, this derivation provided for you, it's up to you if you want to write the derivation. But I'll recommend you to remember the result. Now you may ask, sir, how to, that's fine, we can write the derivation, it's mathematical. But what's the results physical significances? Okay, so let me tell you this thing. This is what? The glassy slab. Glassy slab means it's a slab which is made of glass. Glass is having reflective index is what? 1.5. And air is having what? mu1. Air again is having what? mu1. Okay. So we can understand this thing. Now let me highlight this and explain you the physical significance. So when the ray of light is entering a glass slab, it deviates towards the normal. It again deviates away from the normal. But one thing is sure, that incident ray is equals to the emergent ray, or this is what? Incident ray is parallel to the emergent ray. Okay. Incident ray is parallel to the emergent ray. This is the result ultimate. So if you want to explain to your friend when the refraction happens to the glass slab, what are the results? Because see, in this time when we are giving the exams like IITG, KCT, derivations are fine, but if you are familiar, if you know the results, results are on your tips, so it will be good for you to apply that. Okay, otherwise you'll be doing derivation in the exam, it will take a time. Result is this: if a light is incident from one side of the slab, when it emerges, the same light, it's not a second light or some other source, but when the same light emerges from the other side of the slab, we comment like this, that incident ray is basically parallel to the emergent ray. Okay, this is a result. Remember it. And a derivation in front of you is this. You take first refraction through this, apply the Snell's law. Okay, keep mu to be general, don't put the values. Second refraction, see, first refraction is from the rarer medium to denser medium, air to glass. Second refraction is here, that is from the glass to air, denser to rarer medium. Okay, that's why when it comes from the air to denser medium, rarer to denser, it deviates towards the normal. When it goes from the denser to rarer, it deviates away from the normal. Okay, this is the second formula. Equate both the equations, you'll get the answer like this, that is thus the emergent ray is parallel to the incident ray. You get the answer like this, that is the emergent ray is parallel to the incident ray. Understood? So text in the chat box, is this thing fine or not? Text in the chat box, students, is this thing fine or not? So did you understood the result? Even if you are not able to understand, just see the derivation, it's very easy. But remember, the request is this, please remember this result. That is the emergent ray is parallel to the incident ray. Okay, one of the students have texted, two have texted good. Lakshmi and the students from JNV Ernakulam. So these are all good students. Okay, I mean, you're serious in the class. At least text yes or no. No, then I will repeat it again. Yeah, Gayatri and Lakshmi and this JNV Ernakulam students always text. That's good. But what about other students? Few students remaining. Okay, maybe you understood JNV, Chitradurga, and other students. Okay, leave. So now write this next heading. First result you got, there is no specific question for this. This is actually a concept based topic. Okay, so let me write it here. Pen. This is actually concept based topic here. Concept based topic. So I haven't given any practice numerical on the next slide as related to this. Okay. So we'll see a new topic. In this, there are many numericals being asked in the test, and also you can think like this, in the exam, the questions may come. Okay. Questions may come. Okay. So, yes.
Sir.
See, you can mute yourself, or if you're facing any doubt, you can ask. What are students doing? So, Srinivasa Rao, please mute yourself. Please, students, mute yourself. See, unnecessary noise you must not make, because other students who are studying seriously, they get disturbed, okay? Because they are very much connected in the session. Okay. So here we are, apparent shift. And now let us let me demonstrate you. Okay, what is this apparent shift actually? See, you are seeing this glass bottle in front. Oh, sorry, this is water bottle in front of you. Okay. I hope, let me see myself here, how it looks. Where is it? Okay, yeah, it is looking. Okay, you're able to see it. So this is a glass bottle in front of you. Okay. Okay. See, my face is here. And now I've put a glass bottle in front of you, which is containing of what? Suppose this is a water bottle, okay, not a glass. Water bottle in front of you, plastic, transparent kind of, translucent, not transparent. So if I keep a water bottle in front of me, you can see, initially you are able to see my face, but now when I keep this thing, maybe you are able to see some blood kind of image of my face on the other side. Okay, so considering this bottle which is filled with water like a glass slab, so the object say me, okay, so you can observe me, how I'm looking on the other side in the camera on your phones. Okay, so similar, what happens actually, what is happening is this. Suppose there is an object in front of the glass slab. This is the object. This is the object in front of the glass slab. Okay, and this glass slab is having the thickness, you can see this T is the thickness of the glass slab. Okay, and mu is the refractive index. Okay, T is the thickness of this glass slab, mu is the refractive index of the glass slab. Okay, you are having the object here. Suppose the ray goes from the object like this. So when the ray enters from this side, look here. Okay, just focus on the PPT. When the ray enters from this rarer side to denser side, that is the glass slab, it will bend. Rarer to denser, it will bend towards the normal. So it's bending like this. But again, at this point, it's like the same case we have seen. Just tilt the photo, just change the photo's angle by 90 degree. So from here, the parallel ray, which is basically incident ray and the emergent ray, will emerge like this. These both are what? Parallel, okay? But when this final ray is extended back like this, when this final ray is extended back like this, so what will happen? When this ray enters into our eyes, we'll observe that the object is not actually here. It is the new location of the object now. So we'll observe like this, that the object is not at O position, it is at O dash position. So there is a shift S of this object. Okay, did you got the point what I'm saying? I'm saying like this, let me explain you in this final overview. Okay, at last, let me explain this at this on the left hand side. See on the left hand side. Okay, suppose this is the object. Okay, let us place the apple here. Erase this ball. Let me let me place here the apple. So this is apple. Let me color this red, 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 red. Let me color with green now. So this is green color now. Okay. So this is green color now. So you can see here that apple from this glass slab is at D distance. Okay. So if you are observing from this side, like this. Okay. So what you observe is this is the, you know, this thing. This is the apple's original position. I'll let me mark it here as O. So on the other side, you will see that apple is not actually at D distance from this glass slab on the other side, but you will observe it to be a distance which is equals to D dash. Okay. So you will find that image of this apple will be somewhat here, like this. Okay. And it is at D dash distance. Okay. And this D dash, of course, is less than D in magnitude. Basically, I will say that there is a shifting of these two positions. I mean, there is a shifting of the object image with S magnitude, which is known as shift, which is basically here equals to T minus D dash equals to S. First of all, text, is this thing clear or not? Text here, students, is this thing clear or not? Yes or no? Then we'll proceed for the next. Answer in the chat box. This much thing is clear कि shift कैसे होगा? Shift is due to the refraction of rays. Then we'll see the next things. Okay, so you have texted here, that's cool. Clear? Okay, good. Gayatri, clear? Okay, good. So now let us see the formula based, I mean, through which we can get this S magnitude. See, again, let me tell you. Look here, don't go into derivations. Now you'll be not seeing the derivations, okay? Applications are important very much in this chapter. But if someone, you know, in the class want a derivation, you can text in the chat box, or you can also text like me on the WhatsApp. Okay, I'll give you the PDF, main theory PDF. Okay, I will upload the PDF on that link, notes, official notes link. Okay, got it? So now next thing is this. Remember this formula. So that S magnitude is given by this formula. That is S is equals to, that is the shift produced in the original objects, or difference between the image which your eyes are seeing on the other side of the slab as compared to the original location. This is the shift. I've highlighted this properly on the notes. You will find it on the PDF. Okay, got it? No? Okay, this is shift. So this is equals to T. T means what? Thickness of the slab. Mu means what? Refractive index. Okay. See, why we used 1 here? Because 1 is actually, see, next formula, if you see, if medium is not air outside the slab, you can see in the previous slide, here we are keeping this glassy slab on the both of the sides, if you see, or also in the top. I can call like this, I've kept this glass slab in air. Okay. So here also the mu surrounding medium is 1, mu of the surrounding medium is 1, mu of the surrounding medium is 1. Inside it is glass slab. We know it is the magnitude is 1.5. Okay. So here also we'll write like this. T is the thickness. T is the thickness of the slab, mu of the surrounding. This is the general formula. So you will consider this formula. Okay, if surrounding is the air, you will keep 1 here. So this will give you again backflip this formula again. Okay. So this is what I will write here. This is the general formula. Note down this formula in your notebooks. Okay. Then we'll proceed further. Now after this, please note it down. Okay, you can draw the diagram. Okay, no need to draw the rays. If you want the derivation, it will be provided to you on the PDF in the notes link, which is given to you officially. So the shift produced in the object is this. If you want me to show you here, like somewhat. So if this is the object O, glass slab is in front. Okay. If we need a very good image for this, will not work with this. If object is like this and the glass slab is like this, okay, let the object to be like this. So that this is the original location of the object. Original location. This is what? It's appearing to our eyes on the other side when we are observing from here. Okay. So the shift in the origin in the original object's location is equals to S. Okay, and its formula is this, that thickness of the slab mu of the surrounding medium upon mu of the slab. If that is air, you'll put mu of the surrounding medium to be 1, and then you will get backflip again the same formula. This thing is clear. Text me yes or no, then we'll solve the questions based on the shift. Text in the chat box, students yes or no, then we'll solve the questions based on this formula. I'm waiting for your answers. Okay, one of the students have texted, that's cool. Clear, sir. Okay, Lakshmi says clear. What about other students? What about Jain Ernakulam students? Okay, maybe same. Okay, so before solving the question, these are some important points. Remember all this. The rays which we are observing in these are paraxial again. Sir, ye to beginning say, yes, it is from the beginning. Whether you start with the reflection, or this cell slab kind of conditions, or whether you say, you'll study in the next slides critical angle. For all of these, rays are paraxial. And medium on both of the sides of the slab should be same. So it's like this, you need to keep the slab in some medium. That's why only, this is the condition. If you keep a slab in some medium, in a space, of course, the surrounding medium will be same only. Same. Shifts come out from the object. Okay, so you can see this here. What is happening? Shift is coming out from the object. Shift is coming out from the object like this. Okay, then it says shift is independent of the distance of the object from the slab. Okay, so that's fine. Okay, even if you keep the object not here but here, shift will be something, but it's independent of the object's location on the other side of the slab. It can be D. D can be anything. D can be of any magnitude. Okay, we'll say like this. D can be of any of the magnitudes. Okay, got it. So next point is this. If the shift comes out to be positive, we say like this, the shift is towards the direction of the incident rays and vice versa. So it's like this, students. If the shift comes positive, it means it is moving like this. Okay, so let me write it here for you. Suppose this is the object. If shift comes positive, it means what? It is moving in this direction. If this S magnitude is positive, it means in this direction. It's like sign and conventions, plus X and minus X. If the shift comes negative, it is in this direction. So this is a question for you. Solve this by using the formula shift is equals to T1 minus mu of the surrounding medium upon mu of the slab. Shift here is equals to T equals to 1 minus mu of the surrounding medium upon mu of the slab. Use this formula to solve this question. Use this formula to solve this question. It's very easy, students. It's for you. It's a class illustration. If you're not able to solve, what's the use? It's a class illustration. Everything is provided. You can see here. They're saying what? Calculate the shift produced by the slab of thickness 15 centimeter. T is given as 15 centimeters. Refractive index mu of the slab is 1.5. and surrounding is air. So air matlab mu1. Okay, one of the students have given the answer. So Lakshmi says like this, 5 centimeter. We'll see. We'll see what the answer is. Okay. Anybody else? I want all the students to answer at least. See, if you're not able to solve the questions in the, in after the class, at least try it in the class here online. No. So I'm giving you 2 minutes. Answer it. Yeah. So JNV Ernakulam students have also texted 5 centimeter. That is the right answer. Okay. Okay, that's enough. I'll be solving now. Just watch it carefully. So the shift here is equals to T is how much? T is the thickness of the slab. Thickness kitna hoga? How much will be the thickness? It's given here 15 centimeters. Okay. 1 minus mu of the surrounding medium is how much? You can see here surrounding medium is having mu value. Kitna hai? Mu value is equals to 1 of the air. Now mu slab will be equals to what? Anyone? 1.5 already given here. Now can't you solve this thing? So if I solve it, you can see it's 10, 5 to the 10, 5 to the 15. This will give you 15. 1 minus 2 by 3 is how much? It's 3 minus 2 by 3. 1 by 3. So you get this last magnitude as this. So 3 1 3, 3 5 15. So you get the ultimate answer as 5 centimeter. Okay. So the shift magnitude comes here positive 5 centimeter. It means what? It means like this. Give the object, if this is a slab, if the object is here, it will come 5 centimeter here like this, in this direction. Clear? Yes or no? What about other students? I hope it's clear. Now students, this question for you, this is a 5-star question. Okay, I'll mark it here as, okay, not let us not give the 5-star. It's a above average 3-star question. You know the star ratings, so it's a 3-star question. Try to solve it, sir, but answer it like man, what this question is asking. Okay, so see here, this is a which kind of mirror, concave or convex? It's bulged in. It's a concave mirror. Okay, this is a glass slab here in front of you. Okay, this is the object in front of you. So you know what going to happen if suppose there is no glass slab? What going to happen? You will use the simple formula of the reflection from the mirror to find the image. 1 by V plus 1 by U equals to 1 by F. We know for concave mirror, the focus is what? Focus you will take here is equals to negative. Opposite to the direction of the incident rays. U also you will take here to be what? Negative. And with the sign conventions, you'll put the value, you'll get the V answer. But here, one thing is changed now. So in front of the object, this glass slab is present now. In front of the object, this glass slab is present. So what's going to happen? There will be refraction, finally emergent ray, which is parallel to the incident ray. But if I extend back this ray now, it will give me a shift here. So now I will take that object distance, which is in addition with the shift. Okay, the after effect of the shift, I will take that object distance and put in this formula. So you can't put now directly just 21 centimeter given here. So first find out the shift, then use this distance as U. Then use this distance as U. Okay, so 21 minus S will be your U. With the sign and conventions, put the value that is negative. ठीक है? I've given you the hint of to solve this question, you know, now you can easily solve it 100 by 100. I mean, you can solve this question yourself. Answer it. You got the hint? Focus, वैसे focus is equals to in the terms of radius and curvature, how much? Now you may ask some students, sir, यहाँ पे तो the radius of curvature they have given. Focus is not given, so how to find the focus? You know, I have given you the value, no? ठीक है? Put it here with the sign convention that is negative. Negative. This you will put as 21 minus s. But for this you need to find negative input, can I make it negative and put? But this s will come out with what formula? It will come out with this st 1 minus 1 by mu, because here the external medium is air again. This thickness. Try to solve it. Others I'll be solving. Solve this question, students. Solve this, students. Okay, now I'm solving it. Last 10 minutes are remaining. I'll solve it. Okay. So watch it carefully. So the question is this. There is a mirror like this. This is observe it carefully. You'll get all the things, you know, concept required to solve this question. This is a mirror and this is principal axis. Okay. Object is lying on this axis, which is at distance of 21 centimeter. Okay. Okay. Suppose if the question is this much only, and they ask from you, find the v, which is the image distance. So how will you find? You are given here the radius of curvature as 20 centimeter. कैसे find करेंगे? Simple. 1 by v plus 1 by u equals to 1 by f. ठीक है? U will be how much? It will be minus 21. F will be equals to minus R by 2, that is 10. From this you will get the V, simple. But now the condition is changed. They have inserted a slab also. Okay. So what they did is this. They have inserted, let me take a color. This will be fun. So they have inserted a slab in between. Like this. Okay. This is a slab. The slab is having the thickness 3 centimeters. Okay. कितना thickness है slab का? The slab is having the thickness 3 centimeter. Okay. And the object is at 21 centimeter. Okay. So if this object shifts here, the shift is S, shown by this slab. So now we'll consider the object's U is not this, but 21 minus S, which is will be the new U for the object. Okay. Let us find this out. But for this, let us see first what the shift is. You know, glass slab ke liye refractive index is 4 by 3. Is it right? No, it's 1.5, 3 by 2. That is for water. So now let us find the shift first. Shift comes out to be thickness is 3 centimeters. 1 minus air surrounding medium mu is 3 by 2. This will give you the answer equals to 1 by 3, that is 1 centimeter. So from this you get shift is equals to 1 centimeter. It means that the object will get shift by to its new location. It will appear to arise from the, because we are considering the rays which are going in this direction. No, because we are considering the rays which are going in this direction. So we'll say shift here is equals to how much? Shift will be equals to 1 centimeter here. So what we're gonna do here is this, that object distance will take 21 minus 1. U is equals to 20 centimeter now. So if we talk about the sign and conventions, I'll write here with sign and conventions U is minus 20, because we are moving against the incident ray direction. Now put this value U here, okay, and then solve it. You'll get the final answer. So the final answer is this, that final image location will be F is minus 10. U is with the sign and convention minus 20. So let us solve this thing. 1 by 20 minus 1 by 10. This will be equals to half minus 1. This is equals to minus 20. So V will be, you will get as minus 20 centimeters. Okay. Minus 20 means in which direction? Matlab, you will say like this, that see, now the radius of curvature of this concave mirror is also at is at 20. Okay. So the final image location will be at 20. 20 means say somewhat here. Okay. This complete distance is 20. So what's going to happen now? And also the object, see, now you can see with the check this thing with the physical significance also. If this object's location is shifted with 1 centimeter, now it will be at U equals to 20. 20 here is what basically the location of the center of curvature. And we have studied in the ray optics initially that if concave mirror is present and if the ray passes from the center of curvature, it will retrace its path and it will form the image there. Okay. So here also I will say, I can just without solving, I can say if the object is at 20 centimeters, because 21 minus 1 is the shift. So if the object is at 20 centimeter, V will be again at 20 centimeter, because the image will form there only. Due to what? Due to retracing of the path, which is as per the physical significance statement. Is this thing clear? So this question ka answer kya hai? The answer is this, that the final image shown by the mirror will be at 20 centimeter, that is from the pole, the center of curvature distance. Okay, got this thing? Yes or no? Students, you got this thing? Yes or no? Okay, you understood. So that was all about today's class. Okay, if you understood the concept, let us do this. Let us go back and do some conclusion. Okay. So ultimately, we have founded this thing. Yeah, that question is homework for you. Remember, don't forget to solve that question in the PDF. Okay, when you download from the notes. Yes, this question. Okay. So apply the formula velocity of the image minus velocity of surface and minus how much? Not minus, it's N2 upon N1. Change and indices, refractive indices, object minus S. Solve this B part. So we can say that we have understood this thing, that when the ray enters on the one side of the glass slab, it emerges out parallelly and there is no any shifting, but there is a parallel shift. See, if I extend this, there is a shift of the same ray when it emerges on the other side. Iska magnitude kitna hoga? If you want to see its magnitude, let me show you this thing. So see this, same case. This is a ray. Let me highlight this. This is a ray passing like this, deviates towards, deviates again bahar. Okay. If you extend this, we'll get the shifting. This is known as basically the lateral shift. Remember this also. Okay, so this is also completed for you. This is known as lateral shift and given by this formula. So this magnitude, the perpendicular difference in the locations of these rays parallel both incident and emergent, is given by this. T is the thickness of the slab. Cos R is the angle of reflection here. This one. I minus R is incident angle minus reflection angle. Got it? Just remember this formula. Okay, in the next class, I'll give you the question which is based on this. Okay, lateral shift topic. Lateral, what's the meaning of lateral, by the way? Anyone? Lateral का meaning क्या होता है? Lateral meaning of lateral is this, like this. Suppose two rays are going this like this. It goes like this and comes out like this. So this perpendicular shifting, parallel shifting is the lateral shift given by this numerical formula, mathematical formula. Okay. So we understood all the things now required for today's class at least. So we got the shift. If shift comes positive, it is what? Towards the ray direction. If shift comes negative, it is opposite to the ray direction from the object. Okay. So now I'm going to end the class. If anybody is facing any doubt, can ask. Or you can leave the class, be happy, and we'll meet in the next class. Okay. Study well. We'll meet in the next class, students. You got it? If you're facing any doubt, can ask in the text box or chat box. Any one of you. If you're facing any doubt, can ask. Yes. Otherwise, we can end the class. Okay. So I'm going to end the class now. Bye bye, everyone. Okay. Bye. Okay. Bye, Genuine Curriculum students. Bye, Swati. Bye, all the students. Okay. So we'll start in the next class from a recall question based on the lateral shift. And then we'll proceed towards the lenses. We'll see the animation also. Okay. Bye bye, everyone. Okay. Take care. Study well. We'll meet in the next week now, I think. Okay. Bye.